In this video, we will discuss about Module 8, Chapter 8, SLAAC and DHCPv6. Okay, so I make, as usual, I made a short or summary of this chapter. Okay, so here first thing we need to discuss about what is the IPv6 address, then what is the structure of IPv6 address, then what is global unicast address, then what is the different methods of generating IPv6 address dynamically in DHCPv6. Okay, then we have a problem here, no calculation like how do we generate EUI. Okay, EUI process, that's the main thing in this chapter. EUI process is the main thing. Okay, so here start with IPv6 address. Okay, so IPv6 is actually a unique address for computers. Okay, so it is 128 bits in length and it contains 8 hextets separated by colon operator. Okay, an IPv4 is also unique address representation, but IPv4 there are some limitations. No, the number of address generated is not huge compared to IPv6 because this IPv4 is only 32 bits and we have 192 168 dot. Okay, there was dot operator and there it was 8 bits, no octets, but here it is hextet. Hextet means 16 bit values. Okay, so 16 bit. Okay, so hextet means not that 8 bit. Okay, 16. Okay, so here see first hextet. Okay, then second hextet, third hextet, fourth hextet, fifth hextet, sixth hextet. Okay, seventh, eight. So like that, 8 hextets are there. Okay, so hextet means 16 digits. Okay, so here it will be 8 hextets and the operator we use to separate is colon. Okay, so 16, 16, 16 into 8, 128 bits. Okay, and here another one concept is global unicast address. Like you have public address in IPv4, in IPv6 it is global unicast address. Okay, the structure is like say example 2001 colon db8 colon acad colon 1 colon colon 1. In this structure, the first 4 hextet, this is the thing called as global unicast address prefix. Okay, global unicast address plus network prefix. The last one, and the first 64 bit is global unicast address with prefix and the last 64 bit is the host or interface ID. Okay, remember this one. The first 64 bit, how do we know 64? This is 16, every part is 16. So 16, 16, 32, then 48, then this is again 64. Okay, now Mr. Y, we have only one digit here. Remaining, what about remaining? It will be 0. So if it is 0, continuous 0 means we will remove the zeros, leading zeros, and we put that number 1 only. Okay, so this first 64 bit is called as global unicast address with prefix. The last the remaining 64 bit is host portion or interface ID. Here we have only one, remaining all zeros. Okay, now what are the different methods of generating IPv6 via dynamic or DHCPv6? Okay, 3 methods are there. Stateless, under that we have SLAAC only. There we have only router. Router will generate the IPv6 address, the gateway, the DNS, everything. And the another one is SLAAC with DHCP server. So here router and server both are there. Okay, router will give you basic information like GUI address. Okay, the remaining information like DNS, then network prefix and gateway all given by DHCP server. Third one is stateful. Here you don't want to use a router or something. Okay, all the information will be given by DHCP server. They will give you all the information. Okay, so here there are 3 techniques. See, the same 3 techniques I mentioned in the diagram. So PC1 wants IPv6 address from R1. Okay, so for whatever techniques we use, stateful or stateless, the router, the PC always contact router only. Okay, so PC send a message, it is called as RS, router solicitation. Say I need a IP address. Okay, you will send the message to R1. What R1 will do? R1 will send back router advertisement, that is RA. Okay, that router advertisement contains information like which method you are going to get the IP, from server or from router. What are the information you are going to get? Either routing prefix only, GUI prefix only, or you will get other information or all together. Okay, So first option is, if the router we are using stateless SLAAC only, means there is only router, okay, there is no server. So first technique, so here the router will send back router advertisements which contains three flag, okay, A flag, O flag, M flag. A flag equal to 1. A means address auto configuration information. So all the addressing information, the DNS server, the gateway, the network prefix slash 64 or whatever, all informations will be given by only the router. O flag 0 means other configuration. Nobody will give you. M flag 0 means there is no modified or managed address. So there is no server there. Only router will give you all information. Okay. Second one, use RA and DHCP server. Now I have router advertisement plus DHCP server also. So here both flag, A flag 1, O flag 1. A flag means the router will give you minimum information like GUA prefix. I'll tell you what is a GUA prefix. Okay, this is called as GUA, this much. See, out of this full address, the first 64 bit is GUA prefix. That information the router will give you. That is A equal to 1. O equal to 1 means other information like DNS server, then gateway, the length, network prefix, all the information will be given by what server. Okay, so 1 minute. Okay. So after that, the third one is stateful DHCPv6. Okay, that means the full information will be given by the server. There is no information given by the router. Okay, it's full information given by the DHCP server. Okay, now these are three options. Okay, so A flag, O flag, M flag. A flag equal to 1 means the router is the only option, so they will give you the address information, default gateway, everything. A equal to 1, O equal to 1 means the stateless DHCP. There we have router plus DHCP server. So router will give you basic information like a routing, this one global unicast address network prefix. Okay, global unicast address prefix, and the other information like which one, DNS server, gateway, and network prefix, the length, everything is given by server, that is O flag 1. Yeah, A flag 0, M equal to 1 means all information will be given by DHCP server, address, other information like DNS, gateway, and every information will be given by server. Okay, so here we have, see, 1 minute. Back. So in between I got a call, my son. Okay, so steps in stateless address auto configuration. The first one, okay, SLAAC, that means here only router is there. So see, PC1 send a message, RS message to router 1. See, the PC1 send an RS message, RS router solicitation and router request. I am requesting router for some advertisements. Okay, I send a request from client to router. Okay, using the multicast address. Now the R1 will send back a router advertisements, and this message will be sent to PC1, back to PC1. Okay, and that information contains GUA. Okay, IPv6, sorry, global unicast address fix information. Okay, see here the PC1 is sending a request, the router will send back RA. RA contains only the IPv6 global unicast address prefix information. Okay, in that case, as we discussed earlier, this RA will set only A flag equal to 1. A flag equal to 1 means it will inform the client that I will give you IPv6 GUA prefix. You have to create your own interface ID or host part. Okay, see here, this is the sample GUA address. Okay, the full IPv6 address. So here in that case, the GUA part with prefix is this one, the first 64 bit. So this is the only thing given by the router. The remaining part, remaining 64 bits, the PC has to make. Okay, that's what mentioned here. Inform the client that you have to use the IPv6 GUA prefix given in the advertisement, and you have to create your own interface ID or host part. Okay, Additional informations like DNS server, then default gateway, maximum transmission unit, everything given by the router only. See the example here. Here 2001 DB8 ACAD1. This is the global unicast address prefix given by the router. Remaining 64 bits. See, only 64 bits are here. We know the IPv6 address is 128, right? So only network part given to you. The remaining host part or interface ID you need to create your own. The PC has to create himself, okay, or itself. In that case, two methods. One is randomly we can generate or EUI-64 method. Clear what I'm telling? Here, the first method is the PC wants an IPv6 address from the router. So PC will send RS message, and in the first technique like stateless address auto configuration, SLAAC, router only means the router will be the only device who will give the information for creating IP address, and he will give the information like gateway, DNS, everything. But here, what the router will do, router will not give the complete IP. Router will just give the global unicast address prefix. Okay, it will give the half portion, 64 bits they will give you. Remaining 64 bits. Mr. Why again is 64? Because the IPv6 is how many bits? 128. Okay, 64 bit is network portion, 64 bit is host portion. So this 64 bit network only router will give you. Remaining 64 host has to generate. Okay, for that generating host part or interface ID, they use two methods. PC will use either random generated number, and they will randomly generate number, or they use EUI-64 method. Mr. What is EUI? You know, in a MAC address we have two parts, OUI and EUI. Okay, the 48-bit MAC address contains two parts, OUI and EUI. OUI means organizational unique identifier. Yani whenever you are buying a Mac, which one? Network interface card from a particular company, the identification of that company is OUI. Maybe that OUI will be same for all the machines in the a particular lab because they may be bought from the same company. Okay. EUI means it is unique. For every machine, there is a unique ID. That is EUI. So here, what I'm going to do, the computer, I told you, the computer has to generate the host part. Given 64-bit GUI part from the router, the remaining 64-bit host part or the interface ID, the computer has to generate. I am using EUI method. Okay. How do I do this? Okay. I will be given the MAC address, 48-bit MAC address. Okay. So this is 48-bit MAC address. Okay. In this 48-bit MAC address, what I will do, I will divide OUI and EUI. Okay. So this is my MAC address means I will divide exactly half. Okay. So first three, after first three, I'll put a portion, I'll put a variable. Okay. A particular hexa variable called as FFFE. Okay. In between OUI and EUI, I will insert a hexadecimal number FFFE. Okay. Now this has become how much bit? 48 plus 16, 64 bit. It is not ending there. Okay. Again, we are going to do another operation. So first thing is, why Mr. you are adding this one? Because I want to generate my own interface ID. I want to make my own IPv6 address. Only thing given by the router is router will give you the GUA, the global unicast address network part. The remaining 64-bit host ID I want to generate. For that, one method is random generation. Anybody randomly generate a ID or interface ID, but here I am using EUI-64 method. In that method, the MAC address of computer, you want to get the MAC address. How do you get the MAC address of computer? You know that, go to a computer, ipconfig/all, you will get a MAC address. In that MAC address, we have OUI part and EUI part. OUI means only organization unique identifier. EUI means extended unique identifier. Okay. So in between, we have to add, insert FFFE. Okay. Now this MAC address of 48-bit has become 64-bit. Now what we'll do, one more step is there. Start from the left. Okay. Then the 7th bit. See here 00 means I divide it into 0 means 4 zeros. Again 0 means 40. Here the 7th bit. Okay. The 7th bit. See 1, 2, 3, 4, 5, 6, 7. This bit I want to flip. Flip means 0 means make it 1. 1 means 0. So here it is 0. I will make it 1. So what happens? This will be converted into 0, 0, 0, 0, 1, 0 will be converted to 0, 2, 3, 0. This one 0, 2. So what happens now? The interface ID will be 0230A3FFFE C71101. Now this 64 bit I want to add with the GUI address given by the router. So GUI address already I have 2001 DB8 ACAD colon 1 colon whatever you have, put it here. Okay, as you have to make a pair 4 4. Okay, like this will be the IPv6 address generated by the computer using the first method SLAAC. Okay, second method is, okay, and here along with this the router will give you the default gateway, DNS, everything. Second method is SLAAC, stateless DHCPv6. Now the DHCP server also is there, not only router, DHCP server. So the router will give you the GUI address, but the other information like gateway, DNS server will be given by route, which one, server. So see here, the PC one send a request. Okay, which one, the router will first send a router advertisement. Okay, so it will tell you that A equal to 1, O equal to 1. That means I will give the router will give you GUI information only. O1 means you have to contact the DHCP server for other information like DNS server, gateway, network preface, everything. Okay, this is second method. And for that, for enabling that one, we need to use IPv6 ND other config flag command in the interface configuration mode. Okay. Then third one, DHCPv6 server. Here it is stateful. Everything will be given by the server. No need for you to request the router. See here, the router will give you a router advertisement. Okay, it will contain A0O0M1. That means you want to contact the server. Server will give you everything, the IP address, the no, you don't want to generate any interface ID. They will give you the, okay. So here the router will give you the which one router will give you a flag only M1. Now the PC has to contact the server for all information, IPv6, this which one, DNS server, everything. Who will give you? The DHCP server will give you. You don't want to generate any interface ID. This is what coming under your chapter 6. Okay, everything. See, router will give you all the IP address configuration. Okay, this is what given in chapter 6. So important thing is what are the different methods of generating IPv6 address in DHCPv6. SLAAC means only router. Router will give you the IPv6 GUI. Then the computer can generate the interface ID by using random generation method or EUI method. Then second one is SLAAC, DHCP server. Now router also there along with server. So router will give you GUI part. The computer will generate the interface ID. They will make their own IPv6 address, but the other information like DNS server, gateway, everything will go given by DHCP server. Then DHCPv6 server means here every information will be given by the router. You don't want to make your own interface ID. The router will, not router, the DHCP server will give you all information. Okay, no need to create interface ID. The server will give you all information. Okay, this is what coming under chapter 8. Don't forget how to calculate this. Okay.